A new Susceptor heating method was evaluated in the manufacturing sector to enhance automation and feasibility. The aim was to assess reheating times for a piston within a cylinder, both initially at 230 degrees Fahrenheit. Tests using the SMT 5 power supply and HS4W heat station focused on magnetic steel pistons.
Before I run any tests, I'd like to go over the testing setup and the test that will be performed in this video. Here I have the fixture that you have sent us. It is currently, the bottom section of it is now warmed up to 243 degrees F. I'm now waiting for the heat to equalize throughout the whole part. And once it drops down to 230 degrees F, we will start our test. When I will drop this piston assembly into it, we will be monitoring temperature of this piston right here, which is currently removed. That piston will be heated up to 230 using induction. It will be dropped inside the cylinder assembly. It will be left there for 4 minutes. And then it will be retracted and reheated again. And right now we're going to try to determine two things. One is how fast it takes for the piston to be heated up from room temperature to operating temperature, which will simulate the procedure that will be done at the beginning of the day when the system is being warmed up for the first time. And the second thing we want to find out is how quickly we can reheat the piston after it was sitting inside the cylinder for 4 minutes. Now I've set my timer to 1 minute, which will be counting down. I have my coil and thermocouple in place. I'll now start the test. As we approach temperature, you can see the power supply throttling down, of course with better PID setting. This can be smoothed down and made so that it heats up a little faster. With just a simple setting using a proportional band, this is what we're getting. So about 40 seconds. I actually overshot a little bit. But anyways, that gives you an idea. Now for the second test, while I'm waiting for the cylinders to cool down to 230 degrees Fahrenheit and equalize the temperature throughout the whole part, I will now preheat all three of the pistons to roughly 230 degrees. That way we can simulate the operating conditions as much as we can. Now when I have my cylinders and pistons preheated, I'm going to lower the fixture. So now when the piston and coil are back in position, time to reheat. Trying to run this with the temperature controller, I noticed that it throttled down seemingly way too soon, trying to ease into that temperature. This time I will just run it on a time cycle with full power output, trying to slingshot it into the temperature and see if we can achieve quicker heating time. Yeah, I'd say that works a lot better.
Results indicated that the SMT 2/200 power supply met efficiency needs for reheating, suggesting a specific coil design for uniform heating. For continuous operations, an upgrade to a higher power supply was advised. For further information, use the reference number AR3463 7431.